Hello and hi everyone, both online and in the room. Welcome to the Faculty of Civil and Industrial Engineering of Sapienza, University of Rome. I am Leonardo Micheli, Assistant Professor here, and I have the honor to be the host of this event organized within the IEA PVPS Task 13. So first of all, let me thank Ulrike Jan, the task manager, as well as Josh Stein and Josue Malgeri, which are the organizers of this workshop, along with all the speakers and all of you attending both in person and online. So I wish you a very nice event, and I leave the floor to Ulrike.
Thank you very much, Leonardo. And on behalf of the IEA PVPS program, I also welcome all of you to this workshop. And I would like to give very special thanks to our host, Leonardo Micheli, and also to José Malgeri for organizing this event together with our task activity leader, Joshua Stein. And the program which we will have today, you can also find outside in a flyer, so that we will have 3 sessions. And just give me 3 minutes of your attention to explain what is the international collaboration and why we are here for this workshop. And I hope it works one way. Okay. So the Photovoltaic Power System Program is one of the technical collaboration programs of the International Energy Agency. It was founded more than 30 years ago in order to establish solar electricity or the application of PV for solar electricity. And this network consists of 9 technical collaborations on different topics, including reliability and performance. So worldwide, we are represented in 5 continents, and it involves more than 340 technical experts who are working on the different topics. And the reason why we are here in Rome is that during the last 2 days, we had our technical meeting with 50 experts from around the world, and we discussed the current, but also the future work program of our task. Okay, this way. So these are the countries involved in this IEA PVPS, or Photovoltaic Power Systems program. They include, as I said, all 5 continents, and India was just the last member to join. So these countries are sending their experts to work in the different areas, and usually it's a period of 2, 3, or 4 years. And as a result, we are disseminating our work in form of technical task reports or workshops. And this event is a workshop like this. So we've discussed all these activities and results in detail. The reliability of components, modules, and systems is in one of the is one main area. The second one is performance, durability, and application, which includes floating agri-photovoltaic, but also bifacial tracking systems. And we also look into the techno-economic key performance indicators. And we have official experts, but we also have many contributing. And we always look for contributions, mainly from industry, who are interested to work with us in the various activities. And as I said, the main talk and the dissemination and workshop today is on bifacial tracking system, which was coordinated by Joshua Stein from Sendia, who will lead through today's workshop. And next slide. And the report was published earlier last year. So best practice for the optimization of bifacial photovoltaic tracking systems. And if you scan the QR code, you will get the reports for free download. And I just advise you to have a look. So there are various topics also on shading and what is the impact on power optimizers. So just have a look and stay tuned because several new reports will come up in the next months. And with this, I wish you a very successful workshop and keep in touch. Thanks for joining today.
Okay. Good morning, everyone. Buongiorno. I'm Joshua Stein from Sandia National Labs, and I'm going to just give you a quick overview of what is in this report that we published earlier last year, and sort of the motivation for this workshop. Nope, that's not it. Sorry, that's names. Well, I'll speak to it just off the cuff, so we don't lose too much time. Yeah, that one. Okay. No, yep, that's right. All right. So this report, we had 18 contributing authors. It was a work that we spent probably 2 years working on. And the motivation for this report was a study that was done a few years ago, and there's actually been several follow-on studies showing that of all the system designs for photovoltaics around the world, combining bifacial module technology onto single-axis trackers resulted in the lowest LCOE for over 90% of the land area around the world. And it's only in sort of very extreme locations, such as very high latitudes or other places where it's like extremely cloudy, where bifacial trackers are more expensive than other systems. And as a result of that fact, what we've seen is a proliferation of, when you talk about large scale systems, mostly they're being produced with single axis trackers. Some of the early experience with single axis trackers we were talking about this. I mean, there's a variety of challenges when you start bringing moving parts, motors, batteries into outdoor environments. And so there's a lot of challenges, and a lot of the companies that you'll hear from today are, really meeting that challenge by producing reliable technology that can operate for, the operational lifetime, 20, 30 years out in the field. And so our report, we actually talked to a number, almost 20, I believe, tracker companies. We interviewed developers and users and O&M providers for trackers to kind of understand the techno-economic situation for this and some of the challenges. We looked at different tracker types and technology types, looked at tracking algorithms, and you'll hear there's a talk today where you'll hear about some of the advanced tracking algorithms that are being developed. We have also a talk that will go over the performance monitoring and evaluation best practices. So these types of systems, especially when you combine bifacial and moving parts, in order to operate them at the optimal level, you need a whole sorts of sensors. But you don't want too many sensors. You want just the right amount of sensors so you don't spend too much money. So we'll hear about that and some of those best practices. We had a section on comparing performance, like yield assessment models. And we will not hear about that today, but you could read about that in the report. And I'm hoping that we'll hear from some of our industry partners that are presenting a little bit on reliability issues. We'll see. And some of the challenges, because that is one of the things that we're finding is there's a lot of different technology and how you move trackers and controllers and motors and different mechanisms. And so the reliability will be interesting to hear about. And there's also a section in the report about kind of how do you optimize all these techno-economic factors into a profitable PV plant at the end. And so this workshop here represents kind of our final outreach event. But we've had a bunch, from the publishing of a report back in August. We have a fact sheet. We had a PV magazine and a PV tech article. There's been several other events at various workshops and conferences. And I'm going to this is just kind of highlights, and you can read about these highlights in the executive summary or the fact sheets. But we have, important things around these trackers are related to how they respond to extreme weather, because one storm can, cause havoc. PV performance modeling, reliability. Here's a list of the main authors. Oops, sorry. There we go. Sorry, I'm looking at two different things. And then oops. So getting to today's program, the way we divided this up into three different sessions. One that's focused on industry perspectives, and that's what you'll hear in this first session. A second session right before lunch where we'll talk about some of the highlights of the report, and you'll hear from some of the report authors on, so we're going to hear from these companies. And then after lunch, we have a demonstration of some of these tools. So specifically, we have a demonstration of how to use PVLib-Python, which is open source Python library, to actually model the performance of these tracking systems. And then we also will hear from PV Radar, which is a software company that is building interesting tools to help you evaluate, for instance, how you can optimize your PV systems. And so I think we're going to look at a techno-economic analysis of using albedo enhancers, which is something that people have suggested. It's not really happening at large scale, I don't believe, but there's definitely studies out there for how do you put materials on the ground to get more light to those bifacial sessions. So I hope it'll be an entertaining session. We have people online as well joining us, and what we're planning on doing is for the speaker sessions is have all the talks proceed, and then we have a half an hour of a moderated discussion, and we'll have time for questions. So I'd like to introduce Josue Magori from RSE. He's going to moderate the first session with the industry perspectives, and he was my co-chair for this report. So please welcome him, and hopefully we'll have a great day of vibrant discussions. So thank you.
So thank you, Josh, for this kind introduction. Useful to see, to understand how will be organized today the workshop. So we want to start with the first section with the industry perspective. What we will see today, first of all, if you have the agenda, it's good. If you don't have the agenda, you can of course see here. We will see a first introduction from Enel Green Power, experience from the Innovation Lab. Then we will see in a presentation from Gartner Instrument about overcoming challenges for single axis tracker when we talk about a gigawatt scale. And we will see also the experience of a tracker developer from the Valmont Solar. So what are the challenge, which challenge they need to face to ensure reliability in this principal component for PV system. And we will see, as last presentation, the challenges from the perspective of PV developer. So it will be interesting to see all the industry perspective about the experience in using bifacial tracking system. So I will kindly invite all the presenter here, so they can start to come in to present. So all the presenter, please, can take a place here. So the first presentation will be from Fabrizio Bizzarri, which is the head of solar innovation of Enel Green Power here in Italy, who will go in deep about Enel industry. So Fabrizio, the floor is yours with the first presentation.
Good morning to everyone. It's a pleasure to stay here today to work with you through our sum of innovation that we are studying, developing, implementing in our plants. First of all, I want to just identify what we are doing as Enel Green Power. We are the leader in the energy renewable, with more than 1,300 plants in 22 countries, with more than 12,000 employees. In terms of gigawatt installed, it's important to underline that solar is more or less 13 managed by us is 13 gigawatts. And this gives us a lot of know-how regarding not only the installation, but also the operation and maintenance. What is important to underline that we have even inside a factory, the biggest factory in Europe with 3 gigawatts of production. And we produce, just to give you some numbers, more than 5 million of modules per year. And that is equivalent to 40,000 modules per day, but especially 5.5 terawatt hours per year. That can be useful to reduce the CO2 up to 25 million of tons. Trisan is a sort of jewel in the PV panorama, considering that we are starting now from an efficiency of the cell that is around 25%. This is the current situation. We are development. We have a big and strong roadmap to go beyond 27%. That is practical limit of silicon crystal cells. And then after that, we'll aim to implement the tandem technology. So coupling HGT technology with perovskite thin film. Practically, just giving you some main points regarding the HGT technology, we have a very robustness mechanical cells that give us the opportunity to reach the thickness up to 19 micrometers. We have a strong thermostability that gives us the opportunity to produce more energy thanks to the temperature coefficient that is below 0.23, but sometimes we tested the modules is up to 0.15. And finally, we have the best bifaciality in the market, so up to 95%. This is important, the bifaciality, because thanks to that, we can improve our production. And in fact, we start just from this consideration in our development of the cells. And starting at the beginning we are talking about 2015, we start making some tests with the not HGT technology in Chile at La Silla. obtaining very good results in terms of gain of the energy production. So finally, in Chile, we tested 3 different kinds of technology. One was monofacial standard technology. The other was a smart technology with a DC-DC inside the modules. And the third was bifacial. And so we discovered, we find out that thanks to the bifacial application, in a field in which the albedo was not so much high, so you can see even some photo, we discovered that we find out that we have an average value of gain that is more than 12 during the year. Thanks to that, we push a lot in the market the development of the bifacial, and finally, all the market now, we are talking about that 92–97% of the plant at the utility scale using bifacial modules. But coming back to the tracker system, we are working to understand better and even improving the tracking system. For sure, we have to start from the existing mode of working of the tracking system. So typically, we have different kind of tracker mode, a self-diffuse mode, dynamic, cleaning mode, safety mode, curtailment mode. So each of these are relative to a position or a situation in which the tracker can run, considering the different kind of application, the different kind of site. Typically, we have a network control unit that can manage then the tracker control unit through a communication that typically is made by cable or radio or other even new innovative kind of communication. But finally, it's important, this kind of communication, because sometimes the lack of communication brings to a lack of production. So as we will see later. It's important to underline that typically all the suppliers are offering this kind of mode in the working of the tracker. So I want to, first of all, before to explain what we are doing in terms of innovation, it's important to underline, in my opinion, to what are the key features that are important to have, is nice to have, considering the application of bifacial modules in a tracker, in an existing tracker. So it's a sort of desired list, nice to have, but finally it's something that a lot of suppliers are offering, but not all together, not all the list of things nice to have. They are together, they are offering together. So in terms of increasing ground clearance, we would like to have an higher installation. So we know that if we put the modules at a higher level, we can earn some energy in terms of reflection irradiance from the ground. And we can obtain even a benefit coming from the improved ventilation. But obviously, this is something that can be useful in terms of energy generation, but can bring more cost in terms of installation, in terms of solution. So we have to find the break-even point depending from the site in which we are installing the tracker. So another important thing is the optimized tilt angle. So typically, the tracking system can offer up to 6 degrees of the rotation angles, but it's not common. The measure of the supplier are below that numbers. But reaching this kind of number, it's important because you can obviously manage better the direct and reflected sunlight, but also you can even use this kind of application in the agri-photovoltaic, for example, or in a mechanism in which you can obtain. You can increase the robustness of the or the resilience of the tracker to extreme events. Finally, other things are the optimization of ground coverage. For sure, this brings some earn in terms of energy also, but also some increasing of cost, because we can, the best is to have not shadowing, but it means that we have to have more available ground. The advanced backtracking algorithm is something that typically is working well, but sometimes have some issue considering the not perfect plane of the ground. And so there is a lot of development in that direction, considering that we have to, for sure, minimize row-to-row shadowing, but finally take in account that sometimes the ground is not perfectly plane. It means that we can have a lot of issue of shading, and so final reduction of the production. Another important thing that is nice to have for sure is the best albedo that sometimes can come from weather situation, as you can see, or finally better situation in terms of albedo, natural albedo of the site. But sometimes it could be useful even to increase this albedo through some specific engineering activities. So, for example, white gravel or reflective films or light colored sand. So there are many kinds of solutions, but finally we have to fight always with the cost of this solution. Talking about the structure and design adapted for bifacial modules, during the last at least 10 years, but especially in the last 5 years, there was a lot of development and to design better the tracker respect to the bifacial modules, and even different bifacial modules without or with frame, bigger frame or slow frame, bigger modules. You know that we are facing with bigger and bigger modules. So we are now around each module is around 3 square meters. That is, it means that we have to put more iron, but finally we have to manage structural elements to avoid not only blocking light, but also issue in terms of resilience of the tracker. Talking about the intelligent tracking, typically we are making some tests regarding the smart tracking, and AI-driven optimization is something that is already present in all the suppliers, but it's important to understand how it is managed, because sometimes could bring to some issue in terms of losses. So considering that making some change in the typical job of the tracker, that is an astronomical following, could bring it to some more consumption, so some issue in terms of battery that are or power that typically feed the tracker. The machine learning integration is for real-time efficiency improvement is another important things that is typically managed by all the suppliers. Finally, but is not the last, it's very important during the last years, is the resistance to harsh environmental condition. So we need a robust design to withstand with strong winds, snow, hail, and all the extreme weather. You can see we have had even in Italy, Spain, and the United States, big damage in our plant. And it's important to imagine or to have an automatic system that can put the tracker in the stow mode for high wind and hail, but we need even a quickly response of this kind of application. This is an application that we develop inside in our company that can help us to manage better the tracker, the working of the tracker. So considering that typically we have an astronomical system, we know perfectly how it works and exactly which is the theoretical angles that we have to monitor. We need to have it on field. And so finally, thanks to some specific system on field, we can manage, we can obtain the real angle of the tracker, and thanks to the real angle of the tracker, respect to the theoretical angle and astronomical angle that we have to need, we can obtain some alert regarding, for example, this is an example in which the tracker is stopped. You can see this is in red the expected angle, astronomic angle of the tracker, and finally in blue we can see that the tracker is horizontal all the time, so is stopped. In example 2, we can see that the tracker is following, but differently from the astronomic angle, and so finally we know that we have some issue, and these issues are classified, and thanks to that we can have an intervention of the people on field. Finally, the last example is in which all the things are going well. So the red and blue line are exactly the same. This was one of the tools that we have inside to evaluate how is working the tracker in our company, in our field. We develop as an innovation. This is something while some flower is already active on the plants. In the case of smart tracking, we are now in the last 2 years making some tests, understanding which is the best solution that we can implement, and now we can convince also the supplier of tracker to adopt this kind of solution. First of all, we prepare a list of KPI to obtain a smart tracking, for sure understanding which is the best mode of tracking, and so underline and working especially in the quality of communication, because if you want to manage very quickly the situation, the weather condition of the tracker, we need to have a quick and high quality communication between the central network unit and the tracker unit. Finally, we have to monitor in the angle of the tracker, just compare, thanks to our system is possible. Then we have to evaluate, this is not very simple, the power performance, because obviously we have to make a simulation of the situation that could happen, and the situation that we finally have in the real field. Last but not least, it's important in terms of incident. So during the operation, this different kind of application can create eventually even some incident, considering that the plant sometimes we have the people that are working on field. This is the results of a test field that we did in Australia, in which you can see we have some benefit regarding the dynamic managing of the tracker, and effectively we obtain some benefit thanks to manage and to have the feedback coming from the diffuse sensor, the radiation sensor that can give us information about the diffuse irradiation. And finally, managing a 3D dynamic backtracking. And so managing better the existing backtracking that typically is present in the furniture. And finally, considering also the albedo. So the results was that in terms of simulation, we have had for the diffuse a gain that was estimated around 0.5%, while in the reality we observed 1.3%. For the dynamic, we obtained less than foreseen at the beginning through simulation. Thanks to that numbers, for sure, we are evaluating if it is possible to apply in which site for which supplier, considering that nothing is for free. So we have to manage this kind, to obtain this kind of gain, we have to manage all the things. Another project that is important for us, you can see these are some, unfortunately, some results of extreme hail events that we have in Italy. Is a very big hail, more than 5 centimeters. So no one can imagine that, even in terms of standardization for the test that we typically made for a model. So we decide to work in that direction, thinking and put in a first of kind application solutions that are predictive, reactive, and proactive. Also using some instruments and some sensors that can able to not only measure the hail or the dimension of the hail, but also evaluate the development of the hail during the time. So giving us the opportunity to know in a sort of predictive activities what is and if there will be a big hail or not. This is what we are doing for the hail protection. So in terms of predictive solution, we already talked with some provider of nowcasting services, and we manage all the plants in Italy thanks to these services. That is a typically solution in which we can have an hail alarm, and through a standard communication, we can manage through a site manager control room directly the possibility for the operator to change or to put or to evaluate, even thanks to other information coming from the field, the better solution that we can apply. For sure, it's something that we are applying now, but finally, the aim is to obtain an automated solution. So the nowcasting services can directly send the signals to the tracker control that can manage this signal with other signals coming from the field, that are hail sensor or local sensor, and so finally can decide which is the best safe positioning, considering also not only the hail issue, but also the wind issue. And so typically there is a priority in case of wind defense. And we are studying even which is the best stow position, considering the direction of the wind and the dimension of the hail. It's something that we are developing. We are testing in some plants in Italy. And I think that the future could be even important because in the case of a proactive solution, for example, we can have some sensor that can help a lot to designed to prevent the risk of big hail. Other things regarding the innovation on the bifacial tracking is the project Solar Boost Albedo, in which we start to test in a small plant of a big plant, Magdalena in Mexico, 22 megawatt. We put different kind of enhanced albedo material, geotextile and agritela, for example. And finally, we obtain some good advantages in terms of gain. So we obtain a different situation, an initial gain more than 4%. And we make some tests for the material, and the better materials finally results an agritela polymeric system that is also degradable during the years. And so the idea is that the lifetime, the useful lifetime is more or less 4 years. This gives us a good know-how in terms of choosing how and when use this kind of solution for our plants. And now we are in a phase of adoption in some countries that you can see. We have also an innovation lab in Catania, in which we test at the beginning a sort of proof of concept of new idea or new technology. One of that was a tentative done in 2022 to relaunch the dual axis tracker. Because they proposed us, Sology was a startup, an American startup that proposed us this kind of solution that seems good at the beginning, but finally, as you can see, we obtained also a gain, but was not justified by the cost of this solution. But nevertheless, it was a useful lessons that give us the opportunity to understand better how is work the system and which is the possibility in the future to manage this kind of solution. So also in Catania, we manage a different kind of solution for PV floating. And especially I want to underline that the best solution finally was two different kind. One was a fixed solution and another was in tracker solution. We tested in Catania this kind of solution with tracking system, that is a small tracking system solution, just to understand the behavior of the bifacial modules when we are in a lake in which we know that the albedo is not the best as we expect. And finally, the results was very interesting because we obtain for the solution without very simple solution with standard components that we tested in Catania, and an overproduction of 11% respect to fixed solution that was that is also a solution that is give more energy respect a solution like that, thanks to the floaters that are clear floater. But also the solution of X-Float, that is a startup, an Israeli startup, in a plant of 10 megawatt that they build just in a benchmark with a fixed solution, they obtain more than 25% of the performance, or the increase in the performance yield. This thanks to the fact that there is for sure a water cooling effect. That value is more or less between 5 and 10%. That's finally give a gain in terms of energy up to 3%. But X-Float have another advantage in terms of clear color of the support and very innovative support that don't use any kind of mechanical movement, but only hydrostatic system. And this is, it seems a good solution. We are just looking at the evolution during the time of this solution.
In Synchronous is tracked on gigawatt scale. So, Jürgen, the floor is yours.
Thank you for the introduction. Connectivity is king when we have internet connections like here now, where you have to solve problems. Similar things can also happen to the single axis tracker. So if there is no master control information, what should they do? So we were running autonomous here and doing questions, but now we are back on track. And I would like to share with you challenges, what we see in the industry from single axis tracking when you put that on gigawatt scale. And one word about Gartner Instruments. It's originally a test and measurement company, which has a dedicated PV business unit, which is doing utility scale monitoring and control. This is an example of one of the largest power plants in Germany, 650 megawatt, where we do all the hardware, software, and the control features. This is all built systems in-house, so we have the full value chain under control, which is, I think, very important to guarantee reliable energy production into the changing grid. Now, a key part of the whole system is always a power plant controller. When you want to control the system, you have to absorb the signals from the grid, from the operator, maybe from the O&M companies. And then you have to be able also to evolve over the lifetime what your power plant can do. You have to deal with all the voltage and frequency controls within seconds to adapt to that, but you also have to be able to run hybrid power plants. So we do PV plus wind, PV plus batteries, and now also PV combined with electrolyzers. And one subset of our product portfolio are tracker control solutions for companies which are selling trackers. We are doing more than 4 gigawatt of annual shipping of systems like that, and that brings me to the market itself. So roughly 94 gigawatt were the size of the tracker market in 2023. That's roughly $15 billion of market volume, and it's growing. Now, everybody knows the top 10 players, but when you look at the market, it's very fragmented. There are so many players which are around 1 to 2% of market share, and they also want to grow. So the Gartner approach is that we enable them with our tracker electronics, with the communication, and also with all that, with the technology that they can have reliable tracker operation out in the field. What we see in terms of systems is so far the 2P tracker configuration are dominating, but when you look at the Southwest in the US, 1P will come and most likely will dominate more because you have high power utility scale PV modules, more than 700 watt per panel. And this module design, first of all, is putting too much forces on the substructure itself. So 2P is no longer viable. Because you also want to really optimize and have all the mechanical stability. It's not just about cost. Talking about cost, when we do aggressive system cost analysis, you see here in the charts 3 different system costs on a monofacial, south-oriented with bifacial and some gain, and single axis tracking. You see the system costs are going higher, of course, with the track system. LCEs are lower. We calculate that for Riyadh in Saudi Arabia and for Rome. But when you put the tracker into your system, which is roughly 10 to 11 cents per watt peak, you just cannot take that cost and say, I buy it for it. It has to be optimized for your location, because you have to consider, you know, the 1P, 2P, what is the wind, what is the environmental risk, what is my installation cost, what is the price of concrete. So you cannot just take a fixed price and optimize that to the minimum. It also has to work. If you take the tracker system into your consideration, and let's take a 100 megawatt site, you talk about 2,500 devices. That's roughly 3 tons of steel, which have to rotate every day. And then you put 1.3 million euros roughly on the table just for that steel. If this is not rotating, you're risking your energy outcome. So when you invest in trackers, you really have to make sure that you put not higher risk into your balance sheet. It should be the opposite. You really should understand what's going on, because nowadays with that low LC numbers, I mean, this is a very aggressive scenario for fully integrated solutions on a gigawatt scale. The OpEx of part of the LC is in the range of 20 to 30%. And if your OpEx is not as you would expect, you're really impacting your LCE, and this is a higher factor than even the module prices nowadays, when you can get reliable modules for 10, 11 cents, what you can have it sometimes when there is overcapacity. Now, talking about that systems, I want to give you one example of our TraxBlocks project, what we did in Chile. This is a 230 megawatt power plant where you have more than 5,800 trackers, and they are controlled by 46 different wireless tracking controllers. And this communication has to work reliable, that you can really understand what's going on there. This is a picture of the device itself. We will go into the features now in a bit. If you set up systems like that, this is a simple ecosystem of commissioning to get the data in your monitoring platform of 6 different steps. So first of all, you start with the TrackBlocks itself, which can be AC or DC powered, and which has all the batteries included, so you can backtrack in the night if there is wind and so on. Number 2 is that you have to do the commissioning. So you put on the commissioning portal all your digital information there, the GPS information and so on. And then you have already what you expect. Now you have to pair reality with what's designed in the office. This is step number 3. You take the app, scan a QR code of the motor, scan a QR code of the tracker itself, and pair that. Put the mobile phone on the tracker itself, measure the angle, and you send that up. You do that out in the field, then you have a digital picture of the system itself. From there on, you can now remotely control with our remote access service to the data logger, subscribe to different weather forecasts, and run the different tracking algorithms. And then the data is stored in step number 5 in our web portal, where you have then alarming, visualization, all that stuff. So these are the steps which you have to do in the field for a typical tracking system. Now, what are the challenges there? If you go out in the field, it makes sense that you have a platform where you really can optimize the tracker algorithm. So you can also, or our customers can also bring their own platform, their own algorithms that they can compare it. Number 1 is really that you can also run it in different groups. So you can easily compare A versus B. And so you can also adapt very quickly to the control strategies. Another side is when you do our updates, it doesn't make sense to have that updates in the night, because maybe you don't have energy enough for all the 6,000 devices. So you do it during the day, but you are doing one after the other. So that's also smart algorithm, what we have, that you have really scheduled firmware updates, and only one after the other is there. Good. The other thing is that typical errors in the field is that, you know, the mesh network is degrading over time. There are obstacles and so on. And therefore, I took a screenshot from our power plant controller where the tracker algorithms is running, and you see here in the different dots. Let's see if we can run here the video. Oh, yeah, it should run. So it's changing over time. Yeah, it runs here. So you see here the morning to evening, and each dot is the tracker angle. And that should be a very homogeneous picture, but at the beginning, at the end of the day, it's not as homogeneous as you would have it, because when you have the extreme tracker angles, you have communication issues. So it's very important that your tracker can deal with this information, looking for a different band and finds it out. But with that information, collected reliable, and if there is a communication gap, you try to find a different way how to find it. In terms of the smart channel selection, then you have all the data and you know what the tracker is doing. This can be done within seconds in our system, but then you have also the let's say the pipeline, which one should we do should we do next to have control about that. So that's quite impressive, and these are 5-minute steps of 24 hours. So then you have the live angle of the system itself, and then you can compare that, what should be done. What should be done is when we do our PV performance monitoring, I will show you here something in terms of fixed and tracked system. We take our model from the mechanistic performance model, which is using meaningful normalized coefficients, where you then fit that and you can expect the performance behavior. You just need the radiance, temperature, and wind speed. And that's then quite helpful also to use it with clipping system. The model nowadays have to consider clipping as well. And then the MPM is really good that you can predict performance and also look for discrepancies. So now we have also the position that we have a different distribution. This is now a fixed site of full year raw data, just filtered for 50 watt per square meters and so on, where we have the performance ratio site in Arizona, where we do 1 second high resolution albedo information. And then you see also the cleaning intervals on the bottom right. So this also helps to get all the information in place. Now coming to the end, we see also that when you have low LCOE, that doesn't mean that you earn money at nowadays, because there are so many hours in the grid where you have negative prices, so you have to overcome that. And it really helps if you can understand your uncertainty in terms of albedo and all the assumptions, but you can also maximize your profitability, because with tracker algorithms and maintenance strategies and also how you communicate to the grid, this can help you to overcome that limitations. Another thing is quite important when you try to sell the energy to the market. That's why I wanted to talk about the LC and also the power purchase agreements, is that there's at the moment in the market an imbalance between the fair value, what you get in the market, and the wholesale price. For example, in Spain, you get 42 euros per megawatt hour, but the PPA price, what you need to have for the next 10 years starting now, is roughly 70. So there is a gap on that. So you select the right partner, which you go for, the right companies, maybe not just the wholesale market, to be there. And the higher the power plants capacity, the lower the break-even price of the PPAs. Now coming to the end, we have seen here a lot of streamlined activities, what has to be optimized together. And I think what is very important, that similar to the expected module degradation, the tracker products should also be evaluated by their expected availability. So we need realistic assumptions of the tracker, not just assume that they are there and they work every decade without any maintenance. You have also to adapt the services to the time of use, and the tracker algorithm should also be evaluated independently, and also should be prepared for extreme weather conditions. So if there is an hail event, you have the weather forecast, you have the information, you have the weather sensors, you have storms, so all that algorithms can be set up, especially, for example, on our platform, that you're on a safe position and so on, and only commit to what you can measure and control. Do not include external factors in your performance guarantees and so on. And that helps you to mind the gap between the business value and the market value. Because altogether, when we have reliable tracker performance and monitoring combined, this is really king that helps to enable the predictable energy output of systems like that and to maximize earnings on a gigawatt scale. Thank you.
Thank you. Interesting presentation. And the next one will be on tracker. So we will see now the technological challenges from the tracker manufacturer perspective. And the next talk the title is Tracker in Photovoltaic Application, Technological Challenges and Innovation Opportunities. The presentation will be done from Giuseppe De Mofonti, which is a senior consultant in Valmont Solar for the part of Italy. So, Giuseppe.
Okay.
Yes, the floor is yours. 15 minutes.
Okay. My presentation is the focus on the trackers and on the challenge to design the good Bonacia trackers. Okay. In agreement with the argument of this presentation, I will focus two specific points. The first, regarding the technology challenges, I focus my presentation on the extreme weather risk and the mitigation solution. And regarding the innovation opportunity, I will focus on the new requirements, also the presentation before to show the new requirements from the field to develop the safety and good trackers. The agenda of the my presentation will be formed in a very short introduction. I will talk about the extreme weather risk. I will show one slide on the requirements and from the field and the conclusion. Very short presentation of the Valmont solar converter about us. Valmont industry born in the United States in 1946. In Italy, in the 1981, born the convert in Italy as electromechanical industry. In the 2007, the government Italia produced the first trackers, and in the 1981, the Valmont take the converter, and 3 years ago, born the brand Valmont Solar, but for in Italy, the company is a convert Italia for the problem of the commercial economic part. Our products, we produce the monoaxial trackers, 2 trackers, configuration on P2P, discussion about the balance inside the marketing about this solution. In the last years, last 2 years, we working, we propose the agro PV trackers. About the risk, in agreement with the presentation of Fabrizio, for the trackers, but in general for the PV plant, the weather risk is the key point. We have the K hazard for the external load. The K external load is the wind, but we have also the snow. Then we have the ground movements in specific zone of Italy. But we have the weather events. Hail is the new challenges. Then we have the time in terms of the aging and the corrosion and so on. Aggressive environment, again, corrosion. The mitigation is different. We can to mitigate working on to use the consolidated know-how, to use the standard, to use the experience from the field. But it's important also to develop the new know-how. To develop the new know-how, we have to design, test, medium scale test, to do to use the final element analysis, in particular to study the wind. You use the fluid dynamic analysis, and also for the corrosion, also to develop the new coating. We need the results from the lab. In our all these mitigation actions, we have and we need to have a balance with the cost, because all these actions to reduce the risk as a cost. Then we have to balance this cost. If we are producing tracker with 1 inch over the thickness, I think no problem. But the 70% of the cost of the trackers is the steel. Then, okay. In my in my next slide, I focus on our experience to test, to develop this tracker know-how for the wind, using the wind test, wind tunnel test, and fluid dynamic simulation, and our experience to develop to increase the flexibility of the tracker in terms to achieve the stow position. The wind is the very important point for the design trackers. We have two different events when we have a strong wind. We have an increase of the static load in terms of the pressure on the flap, but we have also the dynamic events in terms of the galloping and torsion instability and so on. This is the phenomenon, possible potential phenomenon inside the trackers. About the wind, the scenario now is this. If I use the existing standard, for example, in Europe, Eurocode 3 for the steel structure, we have the problem. We haven't a specific section of this code dedicated to the trackers, but we dedicate to the building, the bridge, and so on. Then the first problem for when we have to design the trackers is we haven't a specific code in terms of the structure. And the consequence is this code sometimes is too much conservative. Too much conservative is okay for the risk, but we have again to balance with the cost. In these last 5-6 years, this increases the new approach to design the track in terms of the trackers is to develop the new know-how using the fluid dynamic simulation and the wind tunnel test. This is an example of the test performed inside the polymer, where we study in this specific case the measurement, the new parameter to evaluate the load on the trackers. A function of the inclination of the panels, or the distance between two lines of the trackers, and so on. And also the direction of the wind in relation to the orientation of the plant. The other topics studied inside the wind tunnel is the instability, in terms of the galloping and the flutter and the torsion instability. This is a three event, is a very critical event in design of the trackers. In the last year, we work in the agro PV plant, and we have started to study this new configuration, because in the agri PV we have two specific point. One is the dimension of the trackers, and because the vertical dimension is very high, we can achieve 4-5 meters, and we have the group above below the trackers, and then we are studying the effect of this barrier on the tracker field on the road, and the first results show a reduction of the pressure on the trackers when we have this barrier below the trackers. This is, but this activity for us, but also for this activity, not only inside the competitor, but inside the other competitor, is in progress. Another point is the flexibility of the trackers in terms of the short time, to reduce the time to go in stock position. We have discussed about the hail, about in the case of the hail, I understand that the time, we have a very short time from when we have the alarm, when we have the problem on the field. 50 minutes, 20 minutes about. Then we have to decrease the flexibility of the tracking in terms to have the short time to go in stock position. Because if we go in stock position in half hours, will be okay for the wind, but for the hail, maybe too late. So we are working to develop a new self-power system, dedicated for single trackers, and to increase also the SCADA device, and also to increase the number of the sensor, because if we have to move all tracker together, it's better if the plant is larger. It's better to have a number of the sensor higher. Then the approach, the final goal of this approach is to reduce the strength 80%, the time to go in a stay position, because we like to move all tracker all together. About the opportunity, also during the presentation before, we discussed a lot about the communication SCADA. Up to now, we receive the input, we use in our product, 90% of our product, the strategy of the tilting is only one, to increase is to have the maximum electric productivity. But in the last years, also during the last presentation, we have the new scenario. One scenario is the new program for the panel. for the bifacial panel. Then we have to improve it to change the tracking program. Then the agro PV, because in agro PV, we have need to have an optimization of the tracking, to have the maximum energy, but also to have a good productivity. And this tracking can change if you have the tomato, or we have another vegetable or another fruit. Then we have the market of the energy. We like to also to put on the table is a tracking. So we have different scenarios. In parallel, we have a lot of parameters to collect and to use to manage. So this is the need of the computer. For us, it's very important to develop a new SCADA using also the old technology information device, IEA also. And in order to manage it, to let all these needs, and at the same time to have a nice combination.
We need to come to the conclusion.
Conclusion. The challenge for me, for the trackers, is the weather, and the opportunity is the new requirements, is the driving force to change. For the innovation opportunity, I see we need to develop the new know-how using the laboratory, the study, the congress, the seminar, everything, to define the new solution, to apply the new technology. But one very important point is to increase or to upgrade the existing standard. Because at the end, when we have a two-stream contract between employer and end users, and we have the bank, the problem every time, okay, where is the reference standard? Where is the code? Then we have to remember all know-how must be to move inside the standard. To have an easy discussion among the people involved in the business.
Okay.
Thanks for your discussion.
Thank you.
Sorry for 1 minute.
Thank you, Giuseppe, also for highlighting the challenges of reducing costs, increasing reliability. So the last presentation is from Pietro Felici from EFE Solare. He's a senior engineer in R&D at EFE Solare. And now we will see which are the challenges that PV developers need to face in installing PV system and in optimize the Bifacial Tracking PV system. So Pietro, the floor is yours.
Thanks. Good morning, everybody. Thanks for the chance to be here to describe our experience in the tracking system with the bifacial PV models. Few words about our company. We are an industrial group focused on solar PV. We are not only an IPP player, but we include also EPC capabilities and O&M capabilities. And this is a unique feature of our company. We are owned by F2E, that is infrastructure found in Italy, and Credit Agricole Assurances. We work in 2 countries, Italy and Spain, and we have a 200-person expert in the PV field and 330 plants for over 1 gigawatt of installed power. you can see here some figures about the installed base in Italy. We are close to 900 megawatt and 300 plants, and Spain. Here we have less plants, but with more power each, for about 200 megawatt of installed base. And this is the increasing curve of our installed base over the years. We are, of course, focused on producing clean energy, reduce the emission of CO2, and integrate the PV systems into the grid so that the PV system can help to stabilize the grid and keep it working also with a big degree of renewable power installed. Coming to the focus, to the focal point of the presentation, in which case we install bifacial PV modules and trackers. Basically, first of all, in a revamping of PV plants, because our installed base is composed mainly by PV plants receiving feed-in tariffs. And so we have to respect the rules of the Italian authorities while we do the revamping or repowering of the PV plants. And in our case, the topic is to increase the efficiency of the PV modules so we can gain free space in the project site, and we can also install additional power that is not receiving a feed-in tariff, but can send to inject to the grid the energy to be sold. And another point very interesting for us for the bifacial PV modules and trackers is the innovative agri-PV plants. We have, of course, greenfield developments, but we have also experimental plants already installed and running in Italy. With reference to our main activity, that is the revamping and repowering of our installed base, there are the preconditions for doing this to be carefully considered. In particular, if we want to move from fixed tilted structures oriented to the south to 1P or 2P monoaxial trackers, we have to consider carefully the site altimetry that has to be suitable to do this. Also, the soil is very important, so the analysis of the soil and the pull-out test have to be done widely in the site area. The shape of the site has to be not too much irregular, and also for the repowering part of the project, the grid connection has to be available without big efforts. Okay. In this case, when the preconditions are respected, we have the main challenge to be overcome, and it is to combine the strict rules set by the public authorities for revamping of the PV plants getting the feed-in tariff and the best practice in PV designs. So we are not working in a greenfield scenario. We have to respect the limit very strictly. For some example are these: the age of the structure can be increased, but only up to 50% of the legacy one. The peak power has to be pretty the same, only 1% increase is possible, and the authorization title prescriptions have to be satisfied also with the revamping and repowering of the PV project. So we studied some ways to overcome the challenges. One is the adoption of the bifacial PV modules because they can grant an additional power, okay? But by by rule of the GSE, this additional power is admissible because it is not certain because it is done by the albedo that is not certain. So in this way, we can get more energy by respecting the GSE rules. Afterwards, we have to install 1P tracker because it could be also suitable from the point of view of the PV design, but the age could overcome the limit by law. So afterwards, we have to design the PV system in order to have a pitch that it is suitable for reducing the shadowing between the lines and the structures, and also when it is possible to keep a free area suitable for the repowering, so for the increase of the PV power. Afterwards, the length of the tracker has to be combined with the optimal length of the string in terms of voltage of the string, and so of the MPPT range of the inverters. The other activity we are very focused is the innovative agri-PV plants. In this case, the preconditions are, if you want, more strict than the standard installation, because the authorization feasibility is currently in Italy very challenging because the rules change very quickly. And so it is not easy to start with a certain development and permits and come to the end with the same rules. And this is a tricky part of the scenario. Afterwards, the type of agricultural activity must be compatible with the existence of the PV system, of course, and also the quality of the soil, the water availability, and a local business of agriculture has to be present. So these are the preconditions to start seriously the authorization step, and afterward to build the systems. In this case, the main challenges is to assure that the agriculture and energy business mutually benefit from each other, and granting a fair and interesting IRR for the shareholders, being then farmers and IPPs in our case. In this case, the issues to be addressed are the ramming depth, age and wage of the trackers, because of course for innovative agri-PV plants, the age of the tracker could be very high. For example, in these days, we are executing an experimental innovative PV system in which the age of the rotation axis is over 4 meters. So, of course, the ramming, the length of the poles, the structure is very important. Afterwards, during the design phase, we have to put together both the needs of the farmers and the electricians, if we consider in particular the operation phase of the project, but also of the IPP, because the tracking system can, of course, help more the agriculture activities or the energy production task, depending on the algorithm. Of course, another point that has to be considered is the safety of the farmers and the electricians, in particular during the O&M operation phase. Thanks to our experience in the sites we started a few years ago, we have some clues to address the challenges. Of course, in this case, the pre-feasibility study and a detailed agronomic plan is pivotal for get the success from the initiative. And afterwards, we learned that the extensive soil analysis and pull-out tests are very important to avoid issues both in the installation phase and also during the operation, for example, for extreme climate phenomenon. Afterwards, also the tracking system has to be optimized because there is a trade-off between energy production and crops that has to be considered. Maybe in certain times during the year, we have to give more light to the plants and so to reduce the energy production. And in other periods, the energy production would be preferred, of course. The coordination of the agricultural activities and the energy production is very important, and also the maintenance of the system is a critical part, because when you have some tasks for the agricultural activity, you should avoid to do the O&M of the PV equipment and vice versa. So both the players, so farmers and electricians and technicians, have to get a knowledge of the activity of the other parts in order to cover the needs of the initiative and be successful. To conclude, we have some examples of projects that we have already delivered with the monoaxial 1P trackers and bifacial modules. These three are projects of our portfolio in Italy. Petrosina and Lotus have monoaxial 1P trackers, and San Marzano is fixed, but it is interesting for the reason we will see very quickly. In this case, we have indicated the gross PR. For gross PR, we consider the actual one. So it also considers the unavailability of the systems, for example, inverters or curtailments or lack of grids. So all the external phenomena are included in the PR gross. So we have in the last year 82% for the Petrosina PV plant that was delivered about 3 years ago, 86% for Lotus in Lazio, that is quite younger, so 2023. And we see for San Marzano, it is interesting because it is fixed, so not tracked. But we have both a section with monofacial PV modules and bifacial PV modules. And the difference of PR is interesting because it is about 5 points. We have here a couple of pictures. So this is with the Petrosina PV plants, and this is one of our experimental innovative agri PV plants, in this case in Calabria, the Scalia demo site. And that's it. Thanks a lot.
Thank you also for remaining time. Good. So now this is the opportunity to launch the discussion. The way we are proceeding now is not only doing questions to these people that already gave a lot of talk. but also to launch a discussion about key topics. For example, one of the key topics could be what opportunity can be created to create so collaboration between the industry and the research for the bifacial tracking system, for the bifacial technology and tracking system. So which are the opportunities do you believe that can be created between industry, between researchers, and between also considering also the policy? How do you feel this? You want, yeah, Roger.
So this is not such a grand one as the policy level, but Roger French, Case Western Reserve University. Do any of the people designing and installing bifacial systems, tracking systems at large scale use the actual topology of the Earth underneath them? So for example, the Japanese have published ASTER, which is the elevation of every point on Earth every 30 meters. And we find this very useful to understand odd behavior of large power plants when the land is moving down and you find out. And yet, of course, we know that mostly people model things as if we are fictional flat Earth people. And I think some scientists a few years ago pointed out that wasn't so true.
Yeah, thank you, Roger.
Any comments from?
I mean, the point is, it's first of all in two steps, I think very important that you have the GPS information of each axis as accurate as possible, number one, so you know what's going there. On a practical point of view, you have then different groups what you can run after each other and optimize and do it on an empirical way. And if you have a tracker algorithm on the Gartner world, you can add that to the system and then it runs in the terrain as for the systems. So this is how we approach it. And I think it's very important that you can measure the gain and then you start to say, okay, that helps. And also take in consideration what is the effort to have that gain in terms of reliability, amount of tracker positions per day, how fast you have to update it. So there is an economic optimum between that. And that's, I think, very important for the asset owner, what kind of strategy he runs on that.
Roger, please. Roger, I comment to your question also from my side. In many European countries, you can get the 1 meter resolution data for free. Some countries like Switzerland or some larger cities typically have it like 0.5 meter or up to 25 centimeters even. And it sometimes depends which license the data is, but you have each individual tree, you have 2 layers. From the laser scan, you have the top layer, which gives you the treetop height, and the bottom layer, which gives you the ground height. So you can even estimate tree influences in the surrounding.
Thank you.
Just to answer, we have a plant with this characteristic in Spain that is working very well. For sure, the single tracker is managed by different algorithm to do that. Is one of the best plants that we have in Spain. It is working very well. So it is following exactly the. It's not a big. Not a big variation. It is smoothly during an hill, so it's not as you can see in the photo that present, but it is working well.
Yeah, I want just to remind for the people that are following us online that they can post questions on the chat, so we can say this question here. Thank you. Please.
Can I ask a very just practical question? I noticed there was a discrepancy between stow positions that you showed. Anil showed like for hail, you point away from the wind direction, and which obviously would, and also you said that you should stow primarily to protect from wind. That was the priority. And Giuseppe, you showed a picture with the wind tunnel where you're stowing towards the wind direction. Can you comment on, is there a standard or an agreement on that? Because that's something that I think a lot of people are
In
interested
the
in.
presentation of the Fabrizio, there is one sentence, for the wind and for the hail could be useful, I don't remember, to have the same stow position. But this is very challenging because for the wind, we have a stow position between -5 +5 or close. For the hail, we have the supposition is the maximum inclination. About the direction of the wind, I don't know. I'm not optimistic because if I remember, the hail is similar to a storm. We have one direction. The problem is every time is if we have two increases, the strength of the panel and the strength of the trackers, or to create an extra device to recover the panel very quickly. In all cases, it's not gratis. Then, because to put the install position, this position in maximum angle, we have the maximum
Force.
static load.
Yeah.
Fortunately, is better for the instability, but for the static load, then it's a challenge.
In our perspective, as an IPP, we have also to consider which is the worst damage. I mean, maybe it's better to preserve the trackers, because if you have a damage on them, you have to spend more money, more time, and more unavailability of a certain part of the PV plants to restore the PV plants. Of course, to have a lot of PV modules damaged is not a pleasure, but the change of the modules is simpler than the trackers. So we have to consider also insurances and other things. Basically, it is not only a matter of physical or mechanical.
Leonardo, there are supposedly people who want to pose questions online, but the chat is not enabled.
Is the chat available?
Yeah. One question is for the first talk, the speaker described the gain from the optimizing tracking system for diffuse irradiance condition. And in this particular case, the simulation underestimated the gain. It was higher in real life. So what was the reason for this? Was the diffuse fraction simulated or measured?
So typically, it's something that we simulate. So the activities, even in lab or in field, is just to understand and monitoring the application of what we simulate. So for sure, it's not simple because it depends even from the site, which there are even a prevalent wind direction, for example, or a different kind of tracker. So sometimes it's even the orography that helps a lot. Some trackers on the border instead in the central. So the consideration for sure starting from the simulation, and then we try to understand if it is possible, if it is convenient. For sure, there are for sure considerations that are not only technical. Technically, it is more simple sometimes. You make a simulation, but you have to consider even the money on field.
Yeah. The second question is there any specific focus on the performance of bifacial PV in snow condition? Because typically, probably there is a lack of data in this case.
Sorry, no, I didn't understand well the question.
Snow condition. There's no condition. Do you have any?
Yes, 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 yeah.
Do you have any specific focus on the performance of bifacial PV system? Where's no.
Yes, for sure. So we have some gain obtained thanks to that. Are not so much because you have these during the winter period, so it's not a great benefit finally. But also we have not so much planned with this issue, so it's marginal in terms of economy generally.
Please, yes.
I want to put also one topic onto the round here. We talk about systems. So I think when we see all the pictures in a few presentations where the PV module breaks, it's always a similar pattern. And I think really you have to design the system and not just go for the PV module, which your purchasing group is going for the lowest price. That has also to be in combination with the tracker system itself, and that should be optimized. So I think that these parties have to talk to each other very, very well and very intensive. And PV modules are qualified for the standard for static load conditions, but when you have dynamic load conditions, you have wind, fluctuating wind very often. Maybe this is also harming the reliability of the system. And I think that's something what should be really considered when you select your systems and when you go for all the independent engineering consultancy.
Yeah, thank you. Another point was regarding the albedo materials in answer, because you said in your presentation that material durability is more than 40 years, but is economically sustainable or cost effective?
We make scouting all over the world to do that. And finally, we found a material that was produced by an Italian company that was convenient, is a cost effective during the lifetime. That is useful lifetime is between 4, 5, 6 years. So then the degradation is high, but it seems good. So there are other issues in the application that are for the permitting, for the environmental impact. And so you have to convince sometimes the municipality to do that. Yes.
Okay.
You have to foresee at the beginning in the phase of design of the plant. If you do as a retrofit, it could be risky, especially in Spain.
Okay, so you have to include also these materials for the cleaning activities over the 4 years or 6 years.
Yeah, you have to declare. Yes, yes, exactly.
Okay, thank you. Please, Franz. Thank you.
Baumgartner, Zurich University. So congratulations to you, all of you. You showed a lot of very interesting technology solutions. But what's about trends in the future? If you talk about agri-PV, we have to combine maybe overhead installations, 4 meters, and or 2 or 3, whatever, if you go to Apple. But the point is, what is the most economic, feasible solution? Do we find their tracker anymore? Or are these fixed installations? What about these vertical integrations if it comes down to kilogram steel per kilowatt peak and the CO2 rucksack? What are these trends? What are your suggestions?
And maybe a follow on to that is, it was a race to the bottom, right? We would have, like as to Jürgen said, you need a certain amount of strength in the system. And you either just, you have to, it's a combination of the tracker and the module. Yeah.
I forgot one thing. 15 years ago, we also developed a mechanical tracking system in Germany. And at that time, the price was 10 times higher and we gained 21% more electricity. And by that money, we could afford to pay the mechanical tracking. But if the price goes down by a factor of 10, I'm not sure if all these mechanical cost reduction could follow.
I tried to show that also in our, let's say, aggressive cost scenario, because when you put trackers into the system, and if they are not doing what you do in what you expect in the simulation, I think you're out. So it's really a decision where you have to understand what can I control and what is my value chain. Let's say if the tracker company is not supporting me with components for the lifetime, that's a risk. But you can put spare parts there, but you cannot put so much liquidity into your storage and so on. And the second thing is that the locations where you put trackers there, I think, has to be very well selected. I mean, the southwest of the US obviously makes sense. There it's, I think, very clear that you have additional gain benefits, but when you have hilly lands, somewhere in Northern Europe or England and so on, the question is tracker really paying off? With increasing, cost of labor and so on, how you repair that things. I mean, we have also our app where you have something like Google Maps where you can get guidance to the next tracker problem, which helps when you have 3 kilometers or square kilometers of an area. But you also still need people there. You still need to replace the parts and so on. And this is also cost. And if it's just one tracker per day, what you have to maintain, that's okay. But if you come in with additional electronics, with additional components, connectors, and so on, you are increasing the probability. So that's why it's really important that it's simple. And also mention batteries. When you want to backtrack in the night, the batteries has to work. The lifetime has to be well understood, and so on. So it's really, you have to have solid engineering and electronics in there, and not just can go with the race to the bottom. If the electronics and communication is not working, your tracker benefit is not there. And I think at the end, the whole system has to be really optimized. So that's a few from our side.
Only one comment from the side of the trackers. The cost of the tracker, 70% is the steel, and the cost of the steel is changing very quickly. But I worked in the field of the steel for a lot of years. When the cost of the steel, 1 kilo of the steel is the cost similar 1 kilo of the Coca-Cola, I think the problem is this: we can't reduce the cost. So we have the cost of steel go down, go bad, and it's low. Then the only way is to use better the steel. Then you have to new know-how, new design. We have to reduce the safety coefficients, generally speaking. Then we have to develop the new know-how, the wind tunnel, the coating. But the market have to accept this know-how. If an example, if I use the coating, the hot coating, the galvanized hot coating, we have an encode. Then the code, you have a model to dimension the coating. And then it's easy to achieve an agreement with the end users. Because, okay, this is the scenario, this is the standard, okay. But if we have this standard, I have to use the weathering steel without coating, the corten, or we have to use an Magnelis, for example, from Arcelor. There is a standard. And then it's not easy to put. When in my last recommendation, we have to improve the standard, is to move the know-how from the laboratory, to inside the standard, to go easily in the market, in the field. This is
As IPP, we have also hundreds of megawatts of tracking system, more than 10 years old, and they are reliable in general. One of the PV plants that we displayed the performance was a revamping of an existing tracking system. So we keep the structure and evolve the motors and control systems. So tracking system, in my opinion, seems to be very reliable and will be the future of PV systems. The combination with agriculture is the tricky part. So you have to be sure that also the agriculture activity takes benefit from the PV system. And for high value agriculture, for example, grapes, olive, and so on, to have a protection from hails, from storms, and so on, due to the tracking system and PV modules is a great benefit. So I'm positive on the, okay.
Okay, so thank you for this session. It's been interesting to see the challenges that the industry need to face with, but they continue and they, of course, invest in innovation, because the challenge means innovation for research centers, but also for industry. So thank you for this session. Now there will be the next session that is a break for you. It's a break, so the part 2 of this workshop will start at 11:30. So see you later.